Okay, standard deviation is a type of measure of variation. Okay, measure of variations. It describes how data in a data set are spread out. Let's see. Where we go? Oh, you sorry. Let me pull that down. Okay, so it describes how data in a data set are spread out. It's okay. Doesn't matter. Okay, we already talked about range, and range is the difference between the greatest and the least values. How spread out again the data is. Okay, interquartile range then. Is the difference between the third and first quartiles. Okay, the difference between the third and the first quartiles. Okay, all of this information can help us look at our data and see how accurate it is, where our scores will fall, how close to the mean we are. Okay, who is taking stats next year? Okay, so you'll use stats to analyze your data. Most of stats is not doing math, but it's looking at the answers and seeing what the answer means. And a lot of these measures of variance will help us understand our data or data and what it all means. Okay, so for our next problem, we're going to find the range, the mean, and the interquartile range of the following data set. Okay, we always want to start by putting them in order from least to greatest. So we're going to enter, put and these are ages of Olympians. Okay? So we want to look at the average, the range, and the interquartile range of the ages of Olympic athletes. So 21 is our first one. Then 22. Then 23. And another 23. Then another 23. Then 25. Another 25. Then two 26s. Then a 27. Then a 28. Or another 28. And then a 29. Okay, any questions with that? Okay, now the range is just the distance from our smallest number to our biggest number. So it's 29 minus 21, which is just 8. So the range of my Olympic athlete's age is 8. That means my data is really close together. Then all of my data falls in the 20s. In fact, all of my data, in this case, falls in the 20s. Does that mean then we want to add up all the numbers? So everyone add up all those numbers. So we just add them all up. Okay, Brett, what'd you get? Just how many when you added them all up? Before you divided? Okay. 326. Okay, then you divide by the number of numbers. And I counted 13. Is that correct? Okay, and so what was the mean? Did anyone get it? 25. Let's just do 25 because it was 0.7, right? 25.07, we'll just leave it as 25. About 25. Now the interquartile range. In order to do the interquartile range, I need to find Q2, Q1, and Q3. Okay, so let's do Q2 first. And that's the median, of your data. So you're going to go 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6. So 25 is Q2. Any questions over that? Then we're going to need Q1, which is the bottom half of my data. I don't take the 25 because that's the Q2. So then I go 1, 1, 2, 2, and then I have both of them. Since they're the same number, I really don't need to do this step, but just to make sure, remember how to find it. 23 plus 23 divided by 2 should be 23. Then we want to find Q3, which is the median of the top half of my data. So 1, 1, 2, 2, and those two are in the middle. So we do 27 plus 28 divided by 2, which equals 27.5. Any questions? Okay, the interquartile range then is Q3 minus Q1. So then 27.5 minus 23, which should be 4.5. Any questions over that? Okay. We're all good. Okay, standard deviation. Again, those of you who are going on to stats next year, standard deviation is a basic number that you'll find pretty much in a lot of your problems that you're going to do. Okay? Stats have some very interesting formulas. Okay, here's one which is standard deviation. Okay? And standard deviation is the measure of how many values in a data set vary or deviate from the mean. The Greek letter sigma represents the standard deviation. So this is sigma. Okay. This right here means the sum. The x by itself is just a value. The x with a line above it is the mean. And n is the number of numbers. Okay. The best way to do standard deviation is to use a chart like this. In your homework, you want to set up this chart. Okay. I'm going to scroll down. Okay, so the first one thing we want to do. Step one, you're going to find the mean. Remember, the mean is just the x with the line above it. So everyone find the mean of this. Add up all the numbers and divide by the number of numbers. Okay, class, what's the mean? 50. I got 50. Do you guys agree? Okay. So you're going to write 50 all the way down here. Okay, step two. Subtract the value, which is your x, and the mean, which is your x with the line above it. So these two values here, you're going to subtract and put them in the next column. So 48 minus 50 is negative 2. Then 53.2 minus 50 is 3.2. Then 52.3 minus 50 is 2.3. Then 46.6 minus 50 is 3.4, and it should be negative. And then 49.9 minus 50 is negative 0.1. Step 3, you're going to square the value minus the mean. Okay, so you're going to take these numbers, negative 2, and square it and get 4. So you're going to take 3.2, square it, and I believe you get 10.24. Then you get 2.3, square it, and get 5.29. Then take negative 3.4, square it, and get 11.56. And then 0.1 squared is 0.01. Okay, step 4. going to add all the values that were squared. Sorry. Add all the values, not that were squared, in this x minus the mean squared. Let's add all these numbers up. And that's going to give you the sum of all the values minus the mean squared, which is that top part of my formula. Okay, in class, what did we get for that? Okay, let's call on somebody. Hannah, what did you get? 31.1. You don't want to round in this case. You want to add it and get an exact number. So 31.1. Make that look prettier. Okay, next step. Step 5. Spell better. You'll plug everything into the formula, which is the standard deviation equals the square root of the sum of x minus the mean squared divided by the number of numbers. What's nice is we already have that top number. After we fill in this chart, that top number is right here. So we have this equals the square root. The top is 31.1, and it's divided by the number of numbers. There's 1, 2, 3, 4, 5 numbers. So it's divided by 5. So in your calculator, you're going to take 31.1, divide it by 5, and you should get 6.22, but it's still square rooted. So you're going to square root that number. So your standard deviation should equal 2.5. Is about 2.5. Not exactly 2.5, but we're going to round to 2.5. Any questions over that? Okay, it is a lot of work, but you have to do it. In your homework, if you skip, there's 2 problems like this in your homework. If you skip them, I will not stamp your homework until you've done them. Okay, it's not hard, it's just long. Okay, now let's show you how we can use that data. So the next is how many standard deviations is 4.6 away from the mean. So most standard deviations are shown within a curve, and I'll show you how to build that curve. So you start in the middle, and this is your mean, which is 50. We found the mean to be 50, which was right here. Okay. Then we're going to move 1 standard deviation above it. To find that, you just add your standard deviation, which is 2.5 to the 50. And you're going to get 52.5. That's your next little bar. You want to make it a little bit smaller than your first line. You're going to do that same thing, but now you're going to subtract 2.5 from 50 to get 1 standard deviation below the mean, which should be 47.5. And put another line about the same. There. Any questions? So you keep doing this. So from here, I'm going to add 2.5 again. And that's going to give me 55. And make my line a little bit shorter. And this is plus 2 standard deviations away from the mean. Do the same thing on this side, but we're going to subtract the 2.5. That's going to give me 45. So this is minus 2 standard deviations away. Do it one more time. Plus 2.5. So it's going to give me 57.5 here. Make my line a little bit shorter. This is plus 3. And then subtract on this side, minus 2.5. And get 42.5. Oopsie, that didn't work well. Minus 3. Any questions? Huh? Because it's a standard deviation. That's what we found here, right? And they're asked, we're referring back to this data, or data. Okay, 2.5 is a standard deviation. So in order to find how many standard deviations is 4.6 away from the mean, we want to write this chart. And then this is what the curve is going to look like. Let's see if I can draw this curve pretty well. That's a really bad curve, but that's okay. You get the idea. Make your curve look prettier than mine. Oh, let's try that again, because I don't like that curve. We're getting there. Okay, something like that. So we want to know where 46.6 falls away from the mean. So we look here. 46.6 is somewhere in between 45 and 47.5. So it's 2 standard deviations below the mean. Any questions over that? Okay. Again, this gives us an idea of where we fall in relationship to everyone else. Okay? We're going to do 2. Now you're just telling me I'm below the data instead of it. Okay? Any questions over that? Okay. So again, this tells us how we're doing in relationship to everybody else. So here our mean is at 50. I'm 2 standard deviations away, which isn't bad. Yes. Can you wait till we're done or no? Yeah? Okay. Thank you. Okay, now I want to talk about the z-score. Z-score is another way to talk about how many standard deviations away from the mean is. This is more of an exact number. Okay, so z-score is the formula here. The value minus the mean divided by the standard deviation. Okay. And z-score, again, is something else you'll use as you get into stats. You'll use it for more in-depth statistics. This is just the very beginning of statistics. Okay. And all of these formulas or values that we're finding will be used to analyze more of our data as we get into stats. Because stats, again, is more like Not what is your answer, but what does your answer mean? Okay. So a set of values has a mean of 85, a standard deviation of 6. Find the z-score for your value. So again, our z-score, let's spell better, equals your value minus the mean divided by the standard deviation. So it's going to plug in our numbers. So 76 minus 85 divided by 6. Everyone does that right now. Jen, what'd you get? Negative 1.5. Okay, so it's 1.5 standard deviations away from the mean, and it's negative, so it's below my mean. Okay, any questions over that? Okay, the next one says use the mean and the standard deviation from above. So we're going to use this data, 85 and 6. From the above, you can find the value that has a z-score of 2.5. So this time, they're giving me my z-score of 2.5, and they want me to find the value. So we're using the same formula. The only difference is the z-score is 2.5 this time. It equals, my value is what's my x, is what I'm looking for. So it's x minus the mean of 85, then divided by the standard deviation of 6. In order to solve this, you're going to cross multiply. So do 6 times 2.5, and that's going to give me 12, half of that, 6 is 3. So 15. And then 1 times x minus 85 is x minus 85. Then you're going to add 85 to both sides. And you're going to get x equals 100. So the value of 100 is 2.5 standard deviations above the mean. Any questions over that? We're all good? Okay, so your homework